Hello, my name is Shay Swindell and I am the Regional Learning Manager for Future Makers. Future Makers is an innovative partnership between the Queensland Museum Network and Shell's QGC Business, aiming to increase students' uptake of and performance in STEM-related subjects and careers. The partnership also aims to increase teacher capability in delivering STEM activities and resources in the classroom. To help achieve this, we develop and deliver STEM professional development workshops to teachers across regional Queensland. These workshops are designed to develop teachers' skills and confidence in delivering innovative and engaging STEM activities and resources in the classroom, and form part of an Australian Research Council project, community-based STEM professional learning for teachers of middle years, led by the University of Queensland. In this video, we will highlight the delivery of one inquiry-based activity from our Lost in Space Teacher Professional Development Workshop, provide an overview of the activity and explore its implementation in a primary classroom. The Lost in Space Teacher Professional Development Workshop supports learning for Year 5 and Year 7 students. The workshop is aligned to the Earth and Space Sciences strand of the Australian Science curriculum and features many hands-on, inquiry-based activities that are ready for immediate implementation in the classroom. One of these activities is Beyond Earth, Shelter from the Elements. This activity is framed as a design challenge and supports learning in both science and design and technologies for Year 5. In Shelter from the Elements, students design a shelter that can protect humans from the hostile conditions of another planet. Students utilise the design process and draw on existing scientific knowledge and understanding to complete the task. During the Lost in Space workshop, we modelled the delivery of this activity and encouraged teachers to work like their students. The teachers investigated the conditions of their chosen planet, designed and created a shelter that would be able to withstand these conditions, considering the properties of materials during this process, refined their designs to improve on their original ideas, shared their solutions, and discussed how they could adapt the activity to reflect their individual classroom contexts and teaching styles. Let's take a look at how two teachers implemented this activity with their students. Andrew and Tina, teachers from St John the Baptist Catholic Primary School in Gladstone, both attended the Lost in Space workshop. At the time, Andrew and Tina taught Year 5 and they often worked collaboratively to deliver lessons to their combined classroom groups. As described in the original activity, students were tasked with designing a shelter that could protect humans from the hostile conditions of another planet, and they utilised the design process to help them complete this task. Andrew and Tina also modified aspects of the activity to better reflect their teaching styles and classroom contexts. Let's take a look at how Andrew and Tina introduced their students to the activity and how they worked through the first stage of the design process. Investigate.
We have been looking at Earth's place in space over the last term. And Mr. Perrott and I thought it might be very interesting. Well, actually, Mr. Perrott and I aren't actually teachers. So we are actually special agents that work for this agency. Yeah, so this is very important. So this is a little bit top secret. So we have some breaking news that no one else in the world knows about yet. But the Australian Space, not even NASA, the Australian Space Agency has found a twin planet to Earth. The reason why we haven't been able to find it before is because of its orbit and its location within our solar system. So here it is here. So it's been orbiting in our solar system, but it's opposite the sun. So we've never been able to see it before.
Andrew and Tina called this newly discovered planet, Planet 9. From this point, the students explored the conditions of Planet 9, and they worked in small groups to compare the conditions of Planet 9 to the conditions of Earth. Andrew and Tina then regrouped the students so they could discuss their findings as a whole class. Andrew and Tina facilitated this discussion and used this opportunity to revise scientific and mathematical understanding.
Hand up and tell me things that only planet Earth has. Mitch.
It has more water than Planet 9.
Okay, tell me another one that you might have popped in there. Over here, yes.
Different diameter.
A different diameter, was it? That's a great word, diameter, isn't it? Hand up and tell me, what does the word diameter actually mean?
It means in the middle across the...
That's right. So, anything else that's just the Earth? Logan?
Earth is more hotter.
Different temperature, it was a hotter temperature, was it? Right. Anything else that's just Earth? Si?
Earth has more gravity.
Gravity was a difference.
Earth can get colder than Planet 9.
Is that right?
Yeah.
How cold does it get on Earth? Yep.
Minus 80 degrees.
Oh, well, how cold does it get on Planet 9?
15.
Sorry?
15 degrees.
15 degrees. Is that, wow, what do we got here? Yep, 15 degrees Celsius. Wow. Okay. And what about heat? Is the heat the same or is that a bit different?
Planet 9's heat was less than Earth's heat.
That's right. All right.
It wasn't gonna
What was the word that we give when we're talking about how hot a place gets? Starts with the letter M.
the maximum.
The maximum. What's the word we give to when we talk about how cold a place gets?
The minimum.
That's right. All right then. Well, what did they have in common?
They had the same atmosphere.
Practically the same atmosphere. Yeah? Over here, yeah?
They both got the same amount of oxygen.
Right. Anything else?
They both have frozen water at
Frozen water at the polar caps. Anything else?
They are both terrestrial. Yes, thank you. The planets.
They're both terrestrial planets, is there? What is that? All right. What do you mean by terrestrial? What do you understand by that word?
Well, Jonah explained to me what it was, and he said they both have life form. I said that they could be habitable by life.
Very interesting point. Well, was there anything else that you thought in the design, or did Agent Barron?
I think they've covered all the topics.
I think so. I think that's what our scientists back at headquarters have found out.
Yeah, that's
right.
I
In the
think
lab.
they're right.
They were in the lab.
They were in the lab.
From here, Andrew and Tina asked students to consider how these conditions might affect the design of their shelter. The students shared their initial ideas as a whole class and then continued their discussions in small groups, with Andrew and Tina mediating their group work through questioning. Some groups considered Planet 9's strong winds, which could reach speeds of up to 100 kilometres an hour. One group determined that their shelter design would need to have strong walls to withstand the wind, while another group decided to add wheels to their shelter design so that it could move in and with the wind.
Right, how have we gone? So strong walls, eh?
We need strong
Why strong walls?
because here it says the wind's 100 kilometers per hour,
That's pretty fast, isn't it?
and that's like nearly a Category 1 cyclone.
You remember that, do you? Like it's almost a Category 1 cyclone. So you need to have
We
walls.
need to have strong walls, like so. What to like if there was ever like a cyclone, because they would be very
Okay.
bad.
Other groups considered the gravity of Planet 9. The groups knew that the gravity on Planet 9 was stronger than Earth, and so they would need to build a structure that could withstand this force. Following these discussions, students moved into the design and create stages of the design process. Andrew and Tina provided the students with an opportunity to view the materials they could use to build their shelters. They also introduced some design constraints for the students to consider and respond to during the design process. Of course, the shelter needed to protect humans from the hostile conditions of Planet 9. The shelter, or the raw materials needed to build the shelter, also had to fit within a specified area.
This is a diagram of the space shuttle that we will be using to travel to this planet. However, as you can see, the inside of our space shuttle is quite limited to the amount of space that we can use in order to transport everything to the planet that we need. And roughly, if this is the size of our astronaut, this is the payload, the size of the payload you're going to have in order to get all the equipment you need to design your spacecraft, your shelter, to build it on the planet. So everything you need needs to fit inside that cylinder, and it will go into our space shuttle here and get transported to Planet 9. And here is our astronaut. This one hired to us from the police.
That's Agent Z.
So your shelter has to comfortably fit this gentleman or lady standing up inside it. And everything you need has to fit inside this cylinder. The last bit of your design constraint is this is the area of land in which you're going to build on. So as you're building a shelter, it will go onto this piece of land.
Finally, Andrew and Tina encouraged the students to move into the testing phase of the design cycle. Students were encouraged to test their shelter designs early and often at various testing stations.
Now, as you're building, you might like to test to see how things are going. And so over here, we have a bit of a testing station. So the other design constraint is really weight. So if we have a really, really heavy shelter, it's going to take a lot more fuel and a lot more time to get there. So even though it's not a huge factor, it's something you might like to consider to see, and at the end we might see who had the lightest shelter, who had the heaviest shelter. So we have some scales that we can use. So you can weigh your design once it's inside, packed, ready to go. You can weigh to see how much it's going to weigh to get there. And we also have some gravity. So once you've built your shelter, you can sit this on the top, whichever way it's going to sit, to see if it's going to hold up to the gravity. So this is to simulate the extra gravity that would be on this planet. Over here we have some wind. So I would expect that as you're designing, you would also be testing and then redesigning.
The students then reformed their small groups to design, create and test their shelter designs. Andrew and Tina moved between the groups to mediate deeper thinking and engagement with the task by asking questions, providing hints, and presenting challenges. They also successfully mediated agentic engagement. The students showed agency and efficacy to complete the task. They came up with creative design ideas and demonstrated conceptual understanding of science and mathematics content and design and technology skills.
Where's your land? That's their land. Here's your land. Put it on there. You want to test it for wind? Oh, interesting, you're using this capsule itself as part of your shelter. Here you go. So just the bottom one, turn it up high. Okay. Oh, this bottom one, flick it up.
It's able to last a bit, but it needs
So what do you need to do now, do you think?
put more weight on it. We need to weigh it down a bit more.
So you could weigh it. What other things could you do to stop it blowing away?
Make it heavier.
Well, heavier is one way, but what else?
Barriers up here, so when it's getting pushed, it's going to stay there. It's not.
So what sort of materials could be used to simulate barriers?
Toothpicks,
Maybe?
straws, or more of these to weight down. But I think we should go with toothpicks.
All right, have a plan. Go back and talk with your group. Work out what you need. Have you tested the gravity?
No.
That might be a good idea before you get much further.
I think that's better. The cool thing is our levels sit perfect. See?
Ah, okay, and all this is going to fit in the cylinder?
Yeah, I'm pretty
You think so? Yeah.
If the whole thing.
So wind and gravity. You want to check both?
I want to see gravity.
Flip it up the other way and then just sit it on top. So what do you think?
I think we need to reinforce reinforce that.
Reinforce, that's a
that's
good word.
more-
What's that mean?
That means like make it stronger and like double things up with stuff.
So how do you think you could reinforce this? What's happening when it's moving? It's sort of
It's
squishing.
washing.
So what sort of
I
things?
I think if we add some more something that holds this up a bit higher, and like
So something inside it or outside it? I don't know. What do you think?
maybe something inside it to like hold it.
From here, the students continued to test and refine their shelters until they were satisfied with its design. Tina and Andrew then encouraged the students to reflect on their group work, to justify why they made adjustments to their design, and explain why they thought their design achieved the goals of the task. Shelter from the Elements is an authentic STEM task that successfully integrates the understandings and skills of the science, design and technologies, and mathematics Australian curriculum learning areas. The design challenge presents a variety of opportunities for students to clarify, apply, extend, and consolidate scientific knowledge and understanding and design and technology skills. It provides a real-world context for students to draw on and utilise mathematical understandings and engineering principles, and it is able to support the agentic engagement of students as demonstrated by Andrew and Tina's implementation of the task. We hope you can incorporate the collaborative, inquiry-based approach to engineering design tasks we have explored in this video into your classroom practice. You may also like to view other resources and activities from the Lost in Space workshop. Your students could participate in a community of inquiry to consider the impacts of space technology from an ethical perspective. Your students could also create a model of the solar system from plasticine or engineer a stomp rocket. You can access these resources and more at our Queensland Museum Network Learning Resources site.